Example 2 on your handout says the following: sketch the corresponding graph for each of the given polynomial functions. So they give us this function, and in order to sketch this function, what we need to do is to be able to figure out the degree, the leading coefficient, in other words, to get an idea of how this function behaves. So in order to get an idea of what this function looks like, we need to collect the degree, the leading coefficient, the end behavior, zeros and x-intercepts, and y-intercept. Okay, so let's start collecting that. Alright, it's good that we get into a habit of doing this. I mean, eventually when you're given a question like that, you won't be getting all this, but we should know what we need to collect in order to get a better idea of what the function looks like. Okay, so what's the degree of this function? Well, we have 3 expressions in brackets. So when you look at the x's, if we were to multiply all of them, if we were to expand these two, we get a quadratic relation, and then if we were to bring this expression, x plus 3, into the quadratic equation, we're definitely going to end up with an x to the power of 3, so we could say that the degree of this function is 3. What is the leading coefficient? The leading coefficient, basically what we need to do to find the leading coefficient is we multiply the coefficient of the x, of each of the x terms. So we have a coefficient of 1 there, another 1, another 1, so 1 times 1 times 1 gives us 1. So the leading coefficient is 1. So 1 times 1 times 1 gives us 1. So that's the leading coefficient. And we know that it is positive too. Okay, the end behavior. So first we know that it's an odd degree function, and it has a positive coefficient, so it moves from quadrant 3 to quadrant 1. So we can say it moves from quadrant 3 to quadrant 1, and once again it's an even degree function with a positive coefficient, therefore it moves from quadrant 3 to quadrant 1. What are the zeros of this? Well, these are the factors, so it's a big clue there. What are the x-intercepts? X-intercepts are basically x equals 1, x equals -2, and x equals -3. And what is the y-intercept? The y-intercept, basically, how do we find the y-intercept? Well, we let x equal 0. So if this is 0, this is -1, this becomes 2, this becomes 3. So 3 times 2 is 6. 6 times -1 gives us -6. So our y-intercept is going to be -6, or more specifically, if we want to say that, is 0, -6 is at that point. Okay, then the next thing that we do once we've collected this data, we can make a table in order to examine the intervals, right? I'm going to write this down as a reference here. Y equals our original function, x minus 1 times x plus 2 times x plus 3, just so that I don't have to move up and down for this. So we make a table to figure out the intervals, right? So we start doing the following, right? So we start from all the way from -infinity to x minus 2, sorry, to x minus 3, right? To x minus 3, see how the function behaves, and then we want to see how it behaves between x minus 3 and -2, and then we also want to see from -2 to -1 how it behaves from to 1, pardon, and then from 1 to positive infinity. Okay, so we want to see. Alright, and just to get a better sense of this, let me move this up a little more. Right, we have the following, right? We know we have this. I'm going to do a rough sketch. I know in your handout you have a very nice grid that allows you to do this. So once again, these are 1, 2, 3. These are our x-intercepts. 1, 2, 3. Okay, is 4, 5, -3, -4, right? And so we know that these are x-intercepts. So -3, the other one is -2. We also have 1. Okay, So yeah, so basically we want to see, right, how it behaves. So how does it behave to the left of -3? So what we do is we basically put in a value. Let's put in a value that it's lower than -3. So let's choose -4. So -4 here. So -4 is going to give us -5. So that's a negative, okay. -4 here, we'll still get a negative, right? -2, and here we get -1. So basically you end up doing negative times negative, positive times negative, negative. So we know that to the left between that range is going to be negative. So we know that over here is going to be below, right, below the x-axis. So at some point, we don't know what that value is. I'm just doing a rough sketch. You can make it a little more accurate on your grid. Now between -3 and -2, so let's choose -2.5. -2.5 minus this, we're going to end up with -3.5, -0.5, and positive. So negative times negative, positive times positive gives us something positive. So over here, between that range, is going to be positive. Now, how about between -2 and 1? So let's make it easier. It's going to be 0, and then of course we know that when we substitute 0 here, we ended up -6. So we know it's going to be a negative value between -2 and 1, and then 1 to infinity. So let's choose 2. Let's choose 2. So 2 minus 1 gives us a positive number, a positive. So it's going to be positive after between 1 and the rest. So we know that roughly this is going to behave like this. So between -3 and 2, it's going to be positive, but then after that it's going to be negative again, so it probably goes down. Now how far down it goes? Well, we already found out that the x-intercept was -6. So -1, -2, -3, -4, -5, -6. Okay, so we know that it's going to be the x-intercept, and let's write this down, -6 here. Right. And basically let's make this line go through that, and then it goes up through 1 again, and between 1 and positive infinity it's positive, right? Okay, so that's a rough sketch of our first example. Let's look at our